Welcome to Kenton Teaches. Enjoy the video.
You begin by confirming the source color space and its metadata, because accuracy depends on knowing primaries and white point. Decode any gamma to work in linear light so math behaves predictably. Set your working bit depth and rendering intent now. Once done, you avoid clipping and posterization later. Make sure to store the original image separately. You'll perform the first transform steps immediately. Linearize, annotate ICC tags, and choose the conversion matrix or profile to use. You now compute the core transform. Convert linear RGB to sequences using the source primaries and white point matrix so colors map into a device-independent space. Once in XYZ, apply chromatic adaptation. Bradford is a robust default to match white points. This preserves perceived hue and neutral balance. Then multiply by the target RGB matrix to project XYZ into the destination primaries. Make sure to clamp or gamut map at this stage. If values, you finish by encoding the transformed linear RGB to the target gamma or transfer function and quantize to the chosen bit depth to produce final pixels. Once done, choose a gamut mapping intent, perceptual for images, relative for accuracy, to handle out-of-gamut colors. Verify results with test patches, soft-proof display simulation, and histogram or delta-E checks. If colors shift, revisit adaptation or matrix choices. Troubleshooting tip. If neutrals tint, recheck white point adaptation and ensure.
Thanks for watching. Please subscribe if this video was helpful.